Another common task you may be given in statics is determine the moment of a force about a particular axis. If you're asked to do this, you need to use the following equation. The moment about some axis, and I'm going to call that axis OA, is going to be equal to the unit vector that defines where this axis points in space. It's going to be dotted with a position vector crossed with a force vector. And this right here is known as the scalar triple product. And we're actually going to put it into a matrix, and we'll be able to take the determinant of a matrix, and it's actually way easier than trying to perform both of these operations. So this is, as the name implies, going to give you a scalar value. It's going to be a negative value or a positive value, but it's going to be a number. If we look at what these variables mean, this vector right here, this is the unit vector OA. It's going to define the direction of the axis. And this is a free choice if the problem or your professor doesn't tell you otherwise. So let's say I have 2 points in space. This is O and this is A. And this is the line that connects them. I'm able to define a unit vector that points from O to A or from A to O. It doesn't matter at all. The only difference this is going to be is if you choose the other unit vector, right? If the correct, quote, correct answer is from O to A and you choose from A to O, you're just going to have a negative value. So your answer is just going to be negative. That's all it means. It means that the sense of the moment is about the other unit vector, the other direction of that unit vector. So it's not a big deal. And you're free to choose unless otherwise specified. At least that's what I tell my students. Now, this position vector R. So I'm going to have some force here. In this position vector R, we have to read the definition very carefully. It's a vector that points from any point on the axis. So from any point on O to A, and I can choose. And it goes to any point on the line of the force. So if it goes to infinity, it goes to any point on the line of the force. And that's what R is. Now, normally these points that you're going to choose are going to be defined in the problems. They're going to be points that are given to you that you know from the problem. It's going to give you a point in space, and it's going to give you dimensions to that point in space. And those are normally the good points to choose. Now, after you have all of these different variables, you're going to put this in a matrix. You're going to have this moment about OA is going to equal to, it's going to be a 3 by 3 matrix. And it's going to be the unit vector. Well, I'm just going to call it U of X, but really it's this term, the X, Y, Z components of that term. So U of X, U of Y, U of Z. Then you're going to have your position vector X, position vector Y, position vector Z, and then your force X, force Y, force Z. You're going to take the determinant and you're going to get a single value. If you get a negative value, we talked about it, but it just means that the sense of the moment is in the opposite direction. If you are asked to get this as a vector, what you're going to do is you're going to take this value. So this vector value is just going to be the magnitude, MOA, and it's going to be multiplied by the unit vector of the axis. So you have that and you calculated the moment vector. And that's all you need to do, and you'll have this as a vector. Okay, now let's look at an example. In this example, I'm applying a force of 60 newtons in the downward z direction. I am asked to determine the moment of a force about the axis AB. And what's the first step? Well, first, I'm going to define my unit vector. So my unit vector, I'm able to point from B to A or from A to B. Well, let's remind ourselves what a unit vector is. A unit vector I'm going to go from B to A. This is going to be the position vector from B to A divided by the magnitude of that position vector. So this means, again, working backwards, I need to find all my points in space. So B is going to be, this is X, Y, Z. It's going to be 2 in the X, 0 in the Y, 0 in the Z. A is going to be 0 in the X. It's going to be 1.5 in the Y. And it's going to be 0 in the Z. Okay, so now this position vector from B to A is going to be, and I'm going this way. I subtract the tail from the head, so it's RA minus RB, if those are my points. So I get minus 2I plus 1.5J plus 0K. Okay, so now the magnitude of this, RBA, is going to be equal to the square root of minus 2 squared plus 1.5 squared. And let me do that on the calculator. So I have the square root of minus 2 squared plus 1.5 squared. This gives me a value of 2.5. That means my unit vector, BA, is going to be equal to minus 2 over 2.5I plus 1.5 over 2.5J plus, and we'll put the 0 in because we'll need the 0 term, plus 0 over 2.5K. And we can simplify this, right? We can say this is equal to, what's minus 2 divided by 2.5? Minus 0.8. What's 1.5 divided by 2.5? 0.6. So this is equal to minus 0.8I plus 0.6J plus 0K. That's my unit vector. Next, I need to define my position vector. That's the next one right here. Okay, my position vector is any point on the axis. So any point on the axis to any point on along the line of the force. Like I said, it's normally defined by the problem that you're given. I know the point A, I know the point B. So I can either choose to go like this, and I know F goes through the origin. The origin's a really nice spot, right? It goes 0, 0, 0. So I know F goes through the origin, so I can either find my position vector here, or I could find my position vector here. It does not matter. I'm going to use the position vector from B, but you can use the position vector from A and do it yourself, and you'll get the same answer. So this position vector of B, from B, is going to be, again, the head minus the tail. So 0 minus 2 is minus 2I. 0 minus 0 is plus 0J. 0 minus 0 is plus 0K. So that's my position vector. Next, determine my force vector. My force vector is 60 newtons. That's given. It's in the minus Z direction. It's only in the minus Z direction. So I know my force is equal to minus 60K. It has no I, has no J components. So now I'm going to take this matrix, and I'm going to put the moment about AB is equal to, I need all three of these rows. So first, my unit vector. My unit vector becomes minus 0.8. Let me put this in first. Minus 0.8, 0.6, and 0. Now I can put this down. My position vector, the second row, is minus 2, 0, 0. My force is 0, 0, minus 60. Now to take the determinant of a 3 by 3 matrix, we're going to copy these two columns. So we're going to have minus 0.8 and 0.6 minus 2, 0, 0, 0. We are then going to we're going to multiply all the terms that are on a diagonal. So that has a diagonal of 3. So we're going to multiply these together, and we're going to add anything that slants this way. Now, in this particular problem, what do I see? I see a 0, I see a 0, I see a 0 in all of these terms. So I know if I do minus 0.8 times 0 times 60, I get 0. 0.6 times 0 times 0, I get 0. 0 times minus 2 times 0, I get 0. Now we subtract everything going the other way. So we're going to subtract this, subtract this, subtract this. Again, most of these terms are 0, but the first one isn't. So the first one is going to be a minus 60 times a minus 2 times a 0.6. And then the next one is going to be a 0, and the next one is going to be a 0. So minus 0, minus 0. And that's the moment about AB. So let's do that calculation. Minus 60 times minus 2 times 0.6. So 70, this becomes 72. I have a minus still there. So this is minus 72 Newton meters. All this minus sign means is the unit vector I had chosen. This unit vector, the moment is actually about the moment vector that the unit vector that points from A to B. So that's the positive sense of this moment. If I'm asked for the magnitude, I take the absolute value of this number and I get 72 Newton meters. If I'm asked for a vector quantity, I'm going to multiply the 72 Newton meters by my unit vector. That's all I have to do. But this is how you take a moment about an axis. If this video was helpful, please consider liking the video and subscribing to my channel because it helps promote my videos on YouTube and helps other people who may be struggling find my content. Thank you.